On page 23, problems you want to see work off of the last assignment. I would appreciate it. I don't care if you got a question or not. Somebody ask a question from the first section on page 23 so that we can try all these. It'll help James out so that he makes sure that he understands what we're doing. Number 7. Problem number 7. They give us a picture. It looks like this. Give me just a second to draw this picture. And they want us to find. Somebody help me out. What's this say? Give me a little more. One more word. Segment in Q. That part's correct. What do we know that we're finding? There you go. The length of segment in Q. How do you know that's a segment, not a line or array? Because you're finding the what? The measurement, the length. How are we going to find the length of this segment from N to Q? What are we going to do with those two? So we got 1 1/4 inches plus 1 inch. What's that give us? 2 1/4 inches. Just add. Other questions on that first part? No other questions on it? Pretty easy. What's the other thing you could be doing instead of adding? Subtracting, if you know the whole thing, right? Second part, down there at the bottom of the page on 23. Find me one of those problems. 19. What's the very first thing, after I write number 19 down, what's the first thing we're going to do to start to solve this problem? Draw. Now he said draw a line. Are we actually drawing a line? What are we drawing? Probably a segment. If you make it a line, that's fine. We don't really need the whole thing. Is that all I need to draw? What else do I need? Another point. Somewhere in there, who knows? Now they told us somewhere in the directions what the name of this point had to be. What did they say the name of this point here had to be? Everybody agree why? How about these 2 points? On 19, so I don't have to keep trying to look back at the book. Did they tell us something about the distance from X to Y? What did they tell us? 3K minus 2. Everybody agree with Silas on that?
Yes.
3K minus 2. Label it that way so that you got some, hopefully you write a little neater than I do because that's sort of hard to read. Did they tell us something about Y to Z? What was it? Plus 4. And did they tell us something about X to Z? 4K plus 38. Test or quiz? We're taking a test or a quiz. You label, you draw all that, label it that way, you get a point. All right? So if we were taking a test or a quiz, you get a point for this. Label and all that. James, that make any sense? Nothing really hard about this. Second thing, setting up your equation. You set up the equation correctly, you get another point. What are you going to do with these 2 segments? Add them together, put them together. Could you do the like terms as you're doing this? Would you guys rather do it that way? Make it a little shorter? So we'll do it that way. got 3K and 7K. What's that give us? You got a negative 2 and a positive 4. What's that give you? So we added this plus this, and we know that that should all equal what? 4K plus 38. I'm going to solve this real quick because your algebra teachers last year did a magnificent job of teaching you how to solve equations. So this is all easy stuff, right? Subtract 4K on both sides. That's 6K. If I do something wrong, somebody please tell me. That's 38 left on that side. Subtract 2 on both sides. Those cancel out. That leaves me with 6K on this side, 36 on that side. Divide by 6 on both sides. And I think K ends up being 6. Did I do that correctly?
Yeah.
Is that our answer? Find YZ. Is that what it said? It asked us to find the variable, so we did half of it. So if this problem's on a test, 1 point here, 1 point for setting up the equation correctly, another point for getting this, but this problem is probably going to be worth 4 points, so if you stopped right there, you get 3 out of the 4. The fourth point is going to be finding YZ, the length of segment YZ. How am I going to find that length? Plug in what? 6. If I put in 6 right here, YZ is there. 7 times 6 plus 4. I'm not going to grade calculators this time. I will grade them next time. Make sure you got a calculator come Thursday. What's 7 times 6? Plus 4? Feeling any of that sink in? Easy stuff, right? You could just stay home every day and do just fine in here because it's such an easy class, right? Other questions on that section? 17. I think it tells us to do the same thing, doesn't it? Same setup. What was this again? Y? X and Z. Hurry up, let's go through this. What do they tell us about segment XY? 4n plus 3. What do they tell us about YZ? 2n minus 7. What do they tell us about XZ? 20? What are you going to do with these two? Add them together. What's 4n and 2n give us? 6n, 3 and negative 7, minus 4. All of that should equal what? Again, point here for drawing this picture, point for setting up the equation correctly, another point for solving it correctly. Those cancel. If I do something wrong, somebody please tell me. Is that correct? And what's the other thing that they wanted us to do this time? Find YZ. That's right here. So I'm going to stick 4 in there. Again, you drag your calculator. You can stick all that right into your calculator. What's 2 times 4? Minus 7. So how long is segment YZ? When stuff comes out like that, that's probably why Silas asked, because he got an answer like 1. He thought, that don't look right, that shouldn't be 1. So the length of this segment is 1. How long is this segment? 19. Everybody agree with that? Really? So From here to here is 19, and this from here clear over to there is 1. That doesn't make any sense. Has to be 20 total. But my 19 is a whole lot shorter than my 1 segment. I put it like that, right? Does it matter the way it's drawn? Don't go by that, because Ebersole drew it. It's on your paper, you drew it. Just means you didn't draw it the way that they were thinking. Other questions? Other questions on, any questions on the next page? Somebody tell me something about that picture. What's congruent? Segment what? Segment NT. And remember, the congruent symbol looks like this. It's an equal sign with the tilde above it. Segment NT is congruent to segment what? TB. What's that tell us about those two segments if they're congruent? Same measurement, same length. Alright, so if I told you that segment NT here was 7 centimeters, what do we know about this length? 7 centimeters, so on, so on, so on. So congruent, make sure you know that symbol, make sure you know how to write it out. This says segment NT is congruent to segment TB. This says segment NT equals segment TB. Geometry form, algebra form. Questions on that other page? Good. 30? 33. Don't be afraid to ask. You see right there, as soon as somebody says, hey, could you do this one? There's probably about 10 other people who need that same question or had questions on that same problem. Before I go any farther, what's that tell us about these three segments? They're all the same. They're all congruent. U, B, W, X. They tell us this one's 3x plus 1. This one's 4x. Ignore that. 4x minus 6. And this one's 2x plus 8. They're all the same. What am I going to have to do? Take the first two. Just because Zach likes the first two better than the others. Doesn't matter. What should you try to do? Make it as what? How about easy? Wouldn't you like to make it as easy as possible? Yeah, so if one of these has something stupid in it, these three are all pretty easy. If one of them has something dumb in it, like parentheses or something extra in it, probably leave it out. So if we take the first two, like Zach said, what do we know about these first two? They're congruent. What's that mean algebraically? They're equal. So 3x plus 1 should equal 4x minus 6. You're going to solve that. Subtract 3x on both sides. 1 equals x minus 6. Add 6. What's x end up being? Ignore that. X equals 7. I don't know what they ask us to find. So segment UX. We're trying to find the length of segment UX. Oh, that goes from here all the way down to there. How are we going to do that? Plug in 7. If I plug in 7 here, what's 3 times 7? 21 plus 1, 22. Seems like some of you maybe forgot your multiplication facts. Nobody's yelling out 21 there. Might have been easier to plug in here. What's 2 times 7? 14 plus 8. That makes it a little harder. Might have to take off your shoes to count all that up, right? You still ain't got enough, right? How many fingers and toes you got? 20, so you come up short. Once we found this one, that's 22. Do we need to plug into all the others? What do we know about all 3 of them? They're all 22. So is 22 our answer? What do we do to get the whole thing? What do you come up with? 66. Whole thing with that problem, when you're setting up the equation, make it as easy as possible on yourself. When you're plugging back in, pick the place where it's the easiest thing to plug in. Don't make it harder than it has to be. Other questions? 32. Do I need to draw this picture on 32? What do we know about those 2 segments? They're congruent, they're equal. So what equation can I set up? Does everybody agree with that? Ignore that stray mark going up through there. What are we going to do first? Distribute, right? 2x plus 7 stays the same. What's 4 times x? What's 4 times a negative 3? Now I'm going to solve this. You might do me a favor and step back here and turn on that fan that's sitting on top of that so-called air conditioning system. Add 12 on both sides. 2x equals, what's 7 plus 12? 19. Now what? Is that going to come out even? 9.5, 9.5. Is that wrong because it didn't come out even? Please make sure you know most things, a higher percentage of all things in the real world aren't going to come out all nice and even. Don't think you're wrong just because it doesn't come out all nice and even in here. What they ask us to find on 32? DE, so the second segment. So we take 9.5. Does it matter which one of these we plug into? Which one you want to plug into? This part or this part? The one without parentheses, so 2 times 9.5 plus 7. Somebody help me out and tell me what all that is.
It's 19 plus 7.
Everybody agree with 26? Other questions? 25. Carpentry. Carpenter has a piece of wood that is 78 inches long. He wants to cut it so that one piece is 5 times as long as the other piece. What are the lengths of the 2 pieces? I got a son that's about your guys' age. All weekend long I spent in the barn trying to make him something stupid that I have no clue why he wants it. But he wants it, so I figured I'd make it for him. So we're out there cutting boards up and stuff, doing stupid stuff like this. Again, Carpenter has a piece of wood, 78 inches long. So what do I know about this whole length? 78. He wants to cut it, so he's going to cut it. Maybe right there, I don't know. So that one piece is 5 times as long as the other piece. He's going to cut it right there. What do we know about this longer piece in relationship to that piece? It's 5 times. So do I just put 5 here? 5x. If I make that 5x, what's this part over here going to be? What am I going to do with these two parts? Add them together. So what? Tell me the equation. 6x equals 78. Somebody help me out with their calculator. Comes out to be 13. So what's 13? Length of this board is how long? 13 inches. How long is the other board? 65 inches. Everybody agree with all that? Anything like that ever going to come in useful?
Yes.
Other questions? $31. Alright, if I just do this. Number one, I dislike this problem. And I hate math people who do stuff like this. This whole thing's 14.4 inches. What's wrong with that? When was the last time you grabbed a ruler or a tape measure and it said 14.4 on it? Never. It's got fractions on it, doesn't it? So why they do stupid stuff like this, all they had to do is make that centimeters or millimeters or meters or something else. Don't make it inches, because inches don't have decimals. They got this split up into how many different segments? 4. What do we know about all 4 of those segments? They're all congruent. So how can I find each one? Take that number, divide it by 4. How many 4s are there in 14? This might be a reason to make sure you have a calculator next time. Everybody loves long division so much. 3. That's 12. How many 4s in 24? So what's the length of this segment from here to there? 3.6. How about this one? 3.6. How about this one? This one? What'd they ask us to find? Q to T. So that's from here to there. How many of those 3.6s do I need? If I could write them correctly. 3 of them. So what am I going to do to find that whole length? Add or multiply either one. Does that look right? 10.8 inches. Dylan, every bit of that makes sense? You're such a genius. Next thing I want you to do, walk up here, you're going to grab those 2 sheets of paper up here, fill in what you need to fill in.
Right back, Cooper.
My brother told me not to do that. Fill in what you need to fill in. We're going to move extremely quickly because I know your algebra teacher taught you all of this last year. We're going to write down a whole bunch of stuff along with this. So distance, length between length of a segment between any 2 points. So if we're trying to find the distance from this point to that point, it's that length. That's what we're looking for. What's something you know about distance?
You have to measure.
That might be. I'm standing here. I start walking. How many paces did I walk? 3. I'm standing here and I start walking. How many paces did I walk? 3. Distance is always positive. It's always got to be a positive number. Don't listen to those silly science teachers, because sometimes they'll tell you that it's a negative number. Don't tell your grandpa I said that. He'll be mad at me. No, I'm just kidding. He knows I think science people are silly. If I got a pendulum goes back and forth, right? Now you start here, that's 0. This way is going to be positive, going the other way is negative. Sometimes you use negative distances in science to do different things. Everything that we're going to do in here is going to be a positive. So when we do this, I'm going to show you the mathematical way in a second to do on a number line, but right now I'm going to show you an easier way. If I wanted you to find the distance from point N to point T, what would you do? So NT equals what? Remember, this means the length of segment NT equals 5. So what I want you to write down here with this, probably the easiest way, on a number line, just do what?
Count.
Just count. That's the easiest way. On a number line, just count. So if I put this problem on the next test, Taryn's doing the test and she just counts. And she writes down 5. Am I going to know if she did the mathematical way or just counted? I'm not going to have a clue. Doesn't make any difference. Do something as easy as you possibly can. So if you're on a number line, you're just going to count the distance. What if I said segment TN? It's the exact same thing. Doesn't matter that I'm going backwards. Makes no difference in this case. It's still 5 units, whatever those units are. Fill in what you need to fill in on this. I would highly suggest on this one, maybe make these bars. The computer won't let me make the bars any bigger. Maybe make them a little bigger. This is the mathematical way to do this if you're on the number line. First thing, looking at these, what's these bars mean? Absolute value. What do you know when you take the absolute value of something? It's always got to be positive. It's like the distance, right? Absolute value is actually the distance that number is from 0 on the number line, and it's always got to be positive. What's these little numbers here tell us, the 2 and the 1? I couldn't hear you. There's 2 different ones, right? So if I just put this, I'm sure I have some smart aleck young person in this class. If I just put that and didn't put the 2 and the 1 in there, what would you tell me the answer was? 0 every time. So I put those in there so that you know you have one x, one number, one coordinate, and then some different coordinate. That's all they mean. Notice here they could be switched around. It makes no difference. So on this is, again, is the mathematical way to do it. x1, x sub 2. These are called, those little 2's and 1's are called subscripts. And they just tell you that your 2 x's are different. They're subscripts, and they just tell you that your x's are different. 2 different coordinates, 2 different points. Give me a number for x1 here.
4.
What's x2 then? So on, so on, so on. Easiest way to find the distance from this point to that point is just do what? Just count. We could use either one of those 2 formulas and plug it into the absolute value and do all the math. What's the first x you want to pick? 4. 4 minus, what's the second one then?
9.
What is 4 minus 9?
5.
Negative 5. What's the absolute value of negative 5? So how long is that segment? What if we turned it around and did 9 minus 4 instead of 4 minus 5, or 4 minus 9? It's absolute value of 5. What's the absolute value of 5? Get the same answer whether you count, whether you do it, either one of those 2 formulas. Pretty easy. On a number line, you're just counting. Anything hard there, Silas? That's easy stuff, right? Keep your notes out. Open up your books to page 27. On page 27, there's a number line where it says example 1. I want you to draw that number line on this number line. Fill in all the numbers, letters, and points, so on, so on. So take a second and do that right now. While you're doing it at your seats, I'm going to do it up here. In this first example, what do they want us to find? Length of segment CF. Easiest way to find the length of segment CF is to do what? So let's do that.
2, 3, 4, 5, 6.
Write that answer down there on your notes. Just count. That's pretty easy. In the book, they're doing it out step by step for you. They're saying the absolute value, and they want you to fill in the stuff. It looks something like this: minus, parentheses, and then that blank, another blank there. What's the coordinates of one of the points? -1. So let's stick that in right there in your books. Write this in. -1 goes in that blank. What goes in the second blank then? Then they actually do all the steps just as one, right? They think they're smart enough to just do all this and just give the answer. What's -1 minus 5? -6. And then what's the absolute value of -6? Fill in that blank. Easy stuff. Problem down at the bottom that says check. Try that real quick. They give you the answers down there. As I'm looking at that, one of those answers just can't be the answer. Which one can't be the answer? -12. How come? Because it's a negative. Distances can't be negative. So instead of having a 25% chance if you just guess, you now have a 33% chance of getting it correct, because you know that first one can't be right. What do they want us to find on this one? Segment AE. So from A to E, the length of segment AE. How'd you find it? Counted? Oops. Went too far, I think. Is this number line the same as that? Oh, it's different. I thought it was the same. So how far is it from A to E? 12? Anybody else get that? Could we have done it the mathematical way? What was point A? -5 minus, what was point E? What's a -5 minus 7? -12. What's the absolute value of -12? Number line's pretty easy, right? Flip over to the next page. On the next page at the top, example 2. Draw that on your third number line there. Draw that number line on that third number line. I think I gave you enough space, I'm not sure, but what do they ask us? Draw the wrong number line again. I did, didn't I? Hang on. Where's A supposed to be? everybody? B is at negative 3. C is at negative 1. Zach, your paper ever look like this? Does your paper ever look like this? D is at 2. E is at 3. So I don't have to feel bad because your paper sometimes looks like mine. And F is at 5. Well, that's ugly. They ask us about what?
Determine whether C, B, and D add
C, B, segment CB and DF. For those two to be congruent to each other, remember this is the congruent symbol. Equal sign with the little squiggle above it. For those two to be congruent to each other, what has to be true about their lengths? Have to be the same. How are we going to figure out the length of CB? How long is it? 2. And DF, how long is it? 3. Is that right? Are they the same? So can we just write this, that they're congruent? Does anybody know what's it mean when you put a slash through something like that? It's not congruent. So you could write it that way. You could just write down not congruent. That would be fine with me. I don't care which way you do it. Real quickly, check down there on that page. It says check, and it says determine whether segment AC is the same length as segment BD. Try that. Tell me here in a second what you get. Are they congruent or not congruent? Not? Not congruent. Everybody agree with that? Dylan, you agree with it just because Miranda said it? You were waiting until she said it?
I didn't hear.
Oh, you didn't hear? You agreed once she said it, so I just thought maybe once you hear Miranda say something, she's always right, so that's the way it is. Find this. Draw in what you need to draw in on your paper there. You what, Cooper? Now we're to harder stuff. You remember the distance formula? Good. And that should be easy. Especially got that calculator laying there. Do all the work for you. Please make sure as you write this stuff down, you write it carefully so that you don't write something down wrong and use the formula incorrectly. With the distance formula, first thing, coordinate system. And we're going to go over this extremely quickly. On a coordinate system, this point right here in the middle is called the what? Origin. And what's the coordinates of that point? 0, 0. Somewhere on your paper there, write this down. The first number in an ordered pair is what? X. Second one is the Y. The X tells you what? right? The Y tells you what? Up or down. Now a lot of you rolling your eyes. Oh my, Ebersole, we know all this. I know you know all this. I know you've been taught it many, many times, but I guarantee you, class this size, when we take our first test or quiz and it's got graphing on it, at least 7 or 8 of you in here are going to get your paper back and go, how'd I miss that? And you're going to do it backwards. And Cooper's shaking his head no. He'll probably be one of the 7 or 8. Make up a point for me. 9-4. I guarantee that I'm going to have a lot of you. They're going to take this 9 and you're going to go up 9. And then to the right 4. And that's not what it tells you to do. What's this tell you to do? Go to the right 9 and then up 4. I'm not saying that you're stupid or anything. You just mess it up because you dealt with slope a lot last year, and slope goes backwards of our points, and you get in a rush and you do it backwards. Another thing over here on my graph. What's wrong with my graph?
It's small.
It's not centered. There is nothing wrong with it not being centered. Please don't put 0, 0 in the middle every single time. Look at the numbers you need, then decide where you want your X and your Y axes at. Alright? Because what's going to happen if you don't look at the numbers first, you start graphing and you end up way up here because you put your graph right in the middle, and then you get confused. Put the X and the Y wherever you want. A lot of problems that we do, the Y-axis is going to go right here. The X-axis is going to go right there because we're only going to deal with the positive stuff. Okay? So a lot of times it'll just be that positive stuff. Does anybody know which quadrant that is? Quadrant 1. So on your paper there, write that. Number 1, quadrant 1. What's true in the first quadrant? X is positive, Y is positive. This is quadrant 2. X is negative, Y is positive. That's a positive. Can't hardly see it, sorry. Quadrant 3. Negative and negative. Quadrant 4. Positive and a negative. No, it's hard to read. Again, what's these little subscripts tell us? Two different X's, two different Y's. What's this number tell us? Is that a subscript? That tells us to square it. Alright, so you got to make sure you don't get the things confused. If I give you 2 points, just made up 2 points there. First thing I do every single time, if I'm trying to find the distance between those 2 points, I do this. That's an X, that's a Y, that's an X, that's a Y. What 2 numbers go in these first 2 spots? What goes here? -2, that'll work. What goes here? 3. You gotta make sure. Another common mistake when people start rushing. They put 3 here, and then guess what they put right here? The 5, because they get in a rush. And that goes there, that goes there, that goes there, that goes there. Got to make sure X's go here, Y's go there. Nothing hard about the distance formula. Calculator will do most of it for you. Again, make sure you got a calculator by next class. I know you don't have a whole lot of space there. Somewhere, find some space on your paper. Write this down, perfect square numbers. Perfect square number is a number. If you take the square root of it it comes out even. It comes out as a whole number. So let's make a list of the perfect square numbers so you'll have them there on your paper. Give me a perfect square number.
Pardon me, teachers, for the interruption.
Lowest one.
If you're a bring your own laptop student, please go to Mr. Poole's room at this time.
No.
Thank you.
That's something we could do during the intervention. Sorry, I said that out loud, didn't I? Give me the lowest perfect square number. Something lower. What's the square root of 1? 1. Give me the next one. 4. What's the square root of 4? That means 2 times 2, right? Next one.
Pardon me, teachers, for the interruption. I apologize. If you are a bring your own laptop and you cannot connect to the Wi-Fi, please go to Mr. Poole's room at this time. Thank you.
Next. Let's go. 9, then what? 16, then what? 25, then what? 36, then what? 49, then what? 64, then what? 81, 100, then what? 121, skip one. 144, then what? 169. Grab your calculators if you got one laying there. This was, what was 144? 12 times 12, right? 169 was 13 times 13. 196 is 14 times 14. 225 is 15 times 15. What is it? 2. All right, I'm going to get rid of that. 256. 289. So what we have? 15, 16, 17. What's 18 times 18? 324. 19 times 19. 361. 20 times 20. 400. Does it stop there? No, but we're going to stop there. So, if you're taking the square root of something, so if we're taking the square root of 121, it's going to come out exactly even at what? 11. These are numbers, these are nice. If we're doing distance formula and your answer underneath that square root, underneath that radical, comes out one of these numbers, and it's going to come out nice and even. If not, then we're going to have to give the decimal answer or give the answer in some other form. And we're going to talk about that next. You don't have to get in your books. All you got to do is find this on your paper, and you're going to graph these 2 points. 4, 3, -3, 7. And we're going to find the distance in between them. As I'm doing this, so I'm drawing my X and my Y axis. Am I just going to put it right in the middle? Look at your numbers. Where do I need the most space at? -7. So negative going down, right? So maybe I do something like put my graph way up here. Put my x-axis way up there. Maybe put my y-axis, something like that. And I still don't have enough. That sucks. That's my y, that's my x. We'll work it out though. How do I graph this first point? Tell me how to move. Over 4. 1, 2, 3, 4. Is that right? What do you mean? Right, 4. 1, 2, 3, 4. Then what? 1, 2, 3. We'll call that point in. How do I graph this point? We'll call it point T. What do I do first? Left. How many? 1, 2, 3, and then what? 1, 2, 3, 4, 5, 6, 7. still, I'm running out of space. Just know that you're down below the graph. That's T down there. Does the graph in this case really make any difference? All it's going to make a difference is that we do the formula right. We'll write the formula out here. I highly suggest that until you get really, really good at doing the distance formula, you write the formula out each time. First thing I do every single time, I write this: parenthesis, minus, squared, plus, parenthesis, minus, parenthesis, squared. I just write the formula out without any numbers or anything, no letters, no numbers in it. Then I'm just going to put in the correct things in those four positions. Four, is that an X or a Y? I put X above that, Y above that, X above that, Y above that, just so I don't make any mistakes. What are my two X's? 4 and -3. Before I go any farther, what ends up happening with this? You can just mark them out, can't you? Negative, minus, or minus a negative is just going to end up being positive. What's my Y's this time? -7 and 3. Oh, hold on now. Because we went 4, -3, then we went -7, 3. We did one way and one the other. Does it matter? No, it makes no difference with the distance formula. With the slope formula that you did last year, it mattered. With this, it doesn't make any difference, so that's fine. If you have a calculator, all this stuff right here underneath there, you could type all of that into your calculator just like it is. I wouldn't type it in with the square root. If you can do it that way, that's fine. I'm not going to show you to do it that way because I'd rather you do it in 2 steps. I'd rather you find the answer to all of this, then take the square root. Because some calculators are a little different and it gets confusing. I'm going to do it out step by step. 4 plus 3 I know is 7. -7 plus -7 and -3 is -10. 7 squared is 49. -10 squared, that means -10 times -10, that's 100. I add those two together and I get 149. Is 149 one of those numbers that was on that list? Boy, that sucks in. Does everybody know what that symbol means? About, approximately. So we're going to round this off. Somebody help me out that has a calculator so I don't have to grab mine. What's the square root of 149?
12.3, I think.
12.3?
Yeah.
And we'll go out one decimal place most of the time. So how far is it from N to T? About 12.3 units.
That was right.
If you have a calculator, do all of this, just type all that in just like it is right there. Once you get that answer, which would be 149, then just take the square root of 149 and get that. I would not try to type in the square root and all that other stuff all at once. Do it in 2 steps. Otherwise, sometimes the calculator messes up, doesn't understand what you're wanting. Now, before we go any farther, other ways, and I'm hoping that some of your algebra teachers taught this, but a lot of times it gets skipped in algebra. If I get the square root of 125, is that going to come out all nice and even? We could just give an approximate answer. If we want an exact answer, this is why I gave you all those perfect square numbers. What you do is you look at that list, and just like reducing a fraction, you reduce this. Watch closely so you understand this, because a lot of problems are going to give you the answer but they're gonna give it to you in this reduced form. What's a perfect square number on your list that'll divide evenly into 125? Evenly. 25. 25 will, right? How many quarters are there in $1.25? So all you do is you split this apart into two separate square roots. Square root of 25 times the square root of 5. What is the square root of 25? That comes out from underneath the radical, out from underneath the square root. This stays underneath the square root because we can't do anything with it. 5 times the square root of 5. We said 12.3 when we rounded off our answer. These two answers, no, that's not right. Sorry. This answer and the decimal answer, if we would have found it, I was thinking we did that same problem, but we didn't. This answer and the decimal answer, same answer, just in two different forms. This is an exact form. The other form would be a rounded off form. Don't make these harder than they are. So did everybody see this last year in algebra? Did you do stuff like that? Maybe. Page 29. Look at page 29. Right here on this graph, we're going to do this problem. The check down at the bottom. What are the 2 points they give us on 29? What is it? 5, 9. Negative 6 what? Negative 4? Is that what you said? It's hard to hear up here. Do we really need to graph it? You can if you want. Alright? Again, this is a graph that I pulled offline. It's got a dot right in the middle. Is that where I want you to draw your X and Y at? No. So ignore that. I just couldn't find a better graph. Alright? Just ignore that. We don't even need the graph. This is an X, that's a Y, that's an X, that's a Y. What am I going to put in these first two spots? Negative 6 and 5. How about the second two? Negative 4 and 9. Now, I'm hoping that some of you catch on after a while. If you have a negative number as your X or a Y, where's the easiest place to put it? The second one. So if I switch these around, and it said 5 minus a negative 6, and I switch these two around, and it said 9 minus a negative 4, what's going to happen there? Change the plus. You could type all that right into your calculator, then take the square root of it. I'm going to do it out longhand. Ignore that stray mark going up through there. That's 11 squared plus 13 squared. 121 plus, what is that, 169, is that right? Square root, that's 290, is that correct? What do we do with that? Take the square root. Somebody help me out because I don't have my calculator right now. 17.1. Everybody agree with 17.1? Now, when you get stuff like this, sometimes they won't even throw a fit if you just leave it like that, square root of 290. That's an exact answer. Maybe you don't reduce it down because you don't know what it'll divide evenly into. All right? So either of those answers would work. Now, the bad thing with leaving it as a square root, if you leave this as a square root of 100, then I'm taking points off. Because what is the square root of 100? 10. That comes out even. You should be able to do that. Something like this one's not going to come out even. I wouldn't throw a fit if you left it this way, if you wrote it this way, or if you figured out there's some perfect square number that'll go into it and you reduced it down. Is this on your notes somewhere? It's not on your notes? Maddie and Julia are hiking at their local state park. Both girls start their hikes at the main shelter, but go on different trails. After 3 hours, Maddie is 5 miles north, 3 miles east of the shelter. Julia is 7 miles east and 2 miles north of the shelter. How far apart are the two girls? I'll tell you what. Yeah. Doesn't matter. You can do this right on that other graph because we're probably going to run out of time anyway. So you can mark out the word problem there on that last page. And just know it's Maddie and Julia's problem. How am I going to do this on this graph? They didn't give me any points. We're going to make it. What are we going to put where? First, we need a what? Starting point, right? Where are we going to put that? Probably at the origin, right? A lot of times you'll make the origin right here. Oops, don't do that. You'll make the origin right here because we'll want everything positive. The bad thing here is they go, let's see how the girls go. So one of them goes 5 miles north. That's all right because that's positive, right? 3 miles east. Is that positive or negative? Positive. So that works. Julia goes 7 miles east. That's positive. And 2 miles north. That's positive. Do we need any negatives here? No. So could we make this, if I could hit the line right there, make that our Y. And this bottom one down here, our X. Yeah. And where are we going to put the shelter? Right there in the corner. If my pen would draw. Which it won't. We're putting the shelter right there. Shelter. Now, how are we going to see where Maddie's at? What did Maddie do? Everybody knows what Maddie did? So what's that tell me to do from the shelter? 1, 2, 3, 4, 5. So she got to here, went 5 miles north, then what she did? 3 miles east. Put her right there. That's Maddie. How about for Julia?
7 miles east.
So what's that tell me to do? 1, 2, 3, 4, 5, 6, 7, and then what? Up 2. That's Julia. What are we going to do here? How are we going to find the distance in between them? Use the formula. But we need the coordinates first, right? What was Maddie's coordinates? Be careful. 3, 5. What's Julia's coordinates? 7, 2. Now we're going to set up the distance formula. What's my x's this time? 3 and 7. So 7 minus 3. What's my y coordinates? 5 and 2. Somebody punch all that in for us and tell me what that comes out before you take the square root. Is that right? 25, anybody else get 25? Yes, no, maybe? What's the square root of 25? Comes out even, doesn't it? So I'll need it properly. How far apart are they? 5 miles. So So a lot of times setting up using real world stuff, just setting it up on a grid. That's your assignment. Do me a favor and grab paper towel. I'll come around and spray your desk off, or spray your desk here in a second. Get a calculator by next time. They will be graded next class. All right, on this problem, it says Chelsea and Amy are sitting in separate cars on the Monogalia incline, whatever that is. Chelsea is traveling up Mount Washington and Amy is traveling down. When the two girls notice each other, Chelsea is a horizontal distance of 212 feet from the lower station and is at a height of 151.6 feet. Amy has a horizontal distance of 435 feet from the lower station and a height of 311 feet. What is the distance between the two girls? First thing I'm going to do here, we're going to give, first, this is what it looks like if I can get this to work. Probably not. So they're passing each other in these cars is what they're doing. One's going up the hill, one's going down the hill. We're trying to see, for some reason, they didn't notice each other when they were right here and it'd be easy and they were 0 feet apart. They noticed each other one was way up and the other was way down. We're going to graph this in a second. But for now, we're going to try to figure out the coordinates of the two girls. So let's do Chelsea. We'll call her point C. Said she had a horizontal distance. Well, horizontal is going across. So that's going to be our X of 212 feet, or 212.0 from the lower station. For height, that's a vertical distance, or that's the Y coordinate, is 151.6 feet. So that's Chelsea's ordered pair. Then we got Amy's ordered pair. Says Amy has a horizontal distance, so that's her X, of 435.3.
Pardon me, teacher's interruption. I need junior class.
435.3 feet, and a height, her vertical distance, of 311, ignore that, 311.3 feet. So those are the ordered pairs for the two girls. 212.0, 151.6 for Chelsea, and Amy 435.3, 311.3. I'll go to this next slide so I can have a graph. We have this graph. Again, on this graph, it's got this dot in the middle here. Ignore it. We don't care about it. We can make it wherever we want. All these distances for these two girls are positive, so we're going to make our y-axis right here and our x-axis, if I can ever draw it. Now I'm going to go up one. Our x-axis right there. The only reason I'm going up one is because my graph won't let me draw it, or my PowerPoint won't let me draw it there. Now when we do this, we have these ordered pairs, 212.0, 151.6, that was Chelsea. And Amy was 435.3 and 311.3. So we're not going to fit on our graph here, we're not going to fit 212 or 151, none of those on here. So what I might do is go by maybe, let's see, we need 435 over and 300 and some up. So I might go by 50s. Or maybe go by 25s and just count every other block. So maybe go 25, 50 there. So this block right, or that one right there is 50, 100. Ignore that. This is 150, 200, 250, 300, 350, 400, and maybe do the same thing going up the side over here. That's 25, 50s right there, 100, 150, 200, 250, 300, 350, 400, and 450, so on and so on. Then you can graph it. Chelsea was 212.0 and 151.6. So we go out to 212, which is going to be somewhere about in here, and up 151.6, which is going to be somewhere about in here. So that's Chelsea. Amy was 435. Should have went out another one here. That's 450 out there. So she's going to be 435. That's out in here somewhere. And up 311. Going up this way, 311 would be somewhere about in there. That's Amy. Do we care that these points are exactly where they're supposed to be? Really makes no difference. All we're trying to do is find this distance. And the way we're going to find that distance is by using the distance formula. So I draw or write out my distance formula here. This is one that if you don't have a calculator, you're probably not going to be able to do it. And remember, these first two are x's, these second two are y's. That's an x. That's an x down there. That's a y. I can draw a y. That's a y. So I want my x's. I'm going to put 435. My pen's a little off. 435.3 minus 212. And then 311.3 minus 151.6. If you don't have a calculator, you're probably not going to be able to do this. I'll be right back. So if I'm doing this on my calculator, again, if you're doing this on one of the TI 30X2S's that I told you would probably be the best to get, you could type all of that right in, and that's what I'm going to do right now. I'm going to type it all in just like it is right there. Parentheses, 435.3 minus 212.0, close the parentheses, square that, plus 311.3. Oh, shoot, I forgot. So I got to go back. I forgot on my calculator, I need another parenthesis, then 311.3 minus 151.6, close the parenthesis, square that, hit equals, and I get this number, 75366.98. So some great big huge number. Then all I'm going to do is I'm going to hit second square root, and I'm going to type in that number, 75366.98, hit equals, and it tells me that my distance ends up being 274.5. If I look back at the problem, the units were in feet. So that means the girls, when they saw each other, were 200 or about 274.5 feet apart. Again, notice our graph doesn't have to be perfect. It's just giving us an idea. It doesn't have to be exact, and we don't have to always go by ones or twos or whatever. We can go by 25s, whatever, so that we can fit it on the graph. And we don't always have to start with our X and Y right in the middle. We started with our X and Y down here because we wanted everything all positive numbers. That's your assignment. Should be on your notes there.